The actuator is the power-operated device that allows us to move the valve and modulate fluid flow rates. As you can see here, actuators come in a variety of shapes and sizes to meet the needs of different valve applications. Upper and lower diaphragm casings house the internal components of the actuator and create pressure chambers that a pneumatic control signal can be applied to. The upper diaphragm casing is removed to access the internal components. The diaphragm is a flexible, pressure-responsive element that the pneumatic control signal is applied to. The diaphragm plate is a rigid plate that the diaphragm pushes against as pressure is increased. The actuator stem is connected directly to the diaphragm plate. A coupling block is typically used to couple the actuator stem and the valve stem. The final component in this actuator is the spring, which provides an opposing force to the diaphragm and will also provide an inherent fail mode. The actuator here on the right is a direct acting actuator, which has the loading connection on the top of the diaphragm casing. The actuator on the left is reverse acting, which has the loading connection below the diaphragm casing. As we increase the pressure, the direct acting actuator on the right extends toward the valve assembly. The reverse acting actuator on the left retracts away from the valve assembly. Now, if the pressure is decreased or lost, the spring will move the actuator stem in the opposite direction away from the valve body. Thanks for watching, and I'll see you in the classroom.